Creating tables. So right now we have finished from the third week. I discussed the conceptual database design, then relationships. Last week, actually this week also I discussed logical database design and relational model. Today we have to discuss creating tables. So this is from the last lecture. You have to understand clearly how to convert the logical database design to the relational model and creating the tables. Then after this lecture, actually next 7th and 8th lectures, I am going to discuss the SQL language, structured query language, and you have a mid-semester exam. That is the MCQ exam. Then after that we will discuss the functional dependencies and normalization, and finally relational algebra. So this is how we are going to discuss the syllabus of our DBMS1. And this lecture you can learn the basic concepts of and principles of the SQL and the different component of the SQL, how to use the SQL and data definition language. Especially SQL has data manipulation language, consists of the data manipulation, data definition language, and to perform the basic create operation. So you have to understand how to create the tables. After relational model, you have to create the tables, and you have to insert the data to the table and modify and delete data from the table. These four is very, very important. And how to use the DML, data manipulation language, to perform the basic database queries. So SQL consists of the data definition language, which consists of create, insert, modify and delete. Then you have to understand the data manipulation language, DML, to perform the basic database queries. You want to retrieve the data, and you have to filter the data from the databases. Then you have to retrieve the data to according to your requirement. So we'll have to discuss, and we will try our best to do some practicals for this creation and retrieve of the data from the tables. Actually lab classes will be started after these lectures. So next you have to understand the structured query language, especially SQL. What is this SQL? Actually SQL was developed by at the IDM in 1975. Actually mid 1975 the SQL was developed, and this is a declarative language. That means says what, not how. The declarative language, when you understand that, it says what, then not how. And SQL is a powerful language still we are using with some database applications. Without these SQL queries, we can't write the database applications. This is very, very important language still we are using. And SQL is an abstract and portable interface to the relational database management system. If we want to retrieve the data by integrating or connecting the tables, definitely we will have to use this SQL. And first of all, let's see these languages in detail. Actually, there are three DBMS languages. Has the data definition language, data manipulation language, and data control language, DCL. This consists of SQL consists of these three. Data definition language, actually I told you before, creating a database, creating tables, updating, deleting and inserting will be done from this data definition language. The data definition language is used by the database administrator, by database designers, to define both schemas. Actually, this is specially used for design the schemas. If you want to create the table, definitely you will have to use this data definition language. Another one is data manipulation language. So what is that? Then once you create the tables or the schemas, normally we call, and are compiled and the database is populated with the data. So after you creating the tables, you have to enter the data to those tables. So users must have some means of manipulation the database to insert, delete and modify data in the table. So you will have to insert the data, you have to modify the data, and you have to edit. Modify means edit. You have to delete the data, unwanted. If there are any unwanted data in the table, you will have to delete the table. So the data manipulation is done by this DML. DBMS systems provide set of operations or a language called the data manipulation language for these purposes. So first you can understand what is data definition language. The data definition language mostly used for creating the databases and the tables and schemas normally we call, and manipulation language we can use to insert the data, delete the data, or edit or modify the data in the tables. Then data control language. This is actually for administrating a database. Normally control language is used to administrate the database, provide the privileges as other activities. So when you have to understand few terminologies they are in the SQL. SQL does not use the formal relational terminology. For an example, formal terminology is relation. Relation in SQL we use the table. Tuple, earlier I explained, tuple is the row or the data of a particular object. For an example, student, one row represents the data of one student. And attribute, formally is the attribute is the table is a column. Column represents the attributes of the attributes in the conceptual model. And cardinality is the number of rows in the table. Cardinality. Degree means the number of columns, how many attributes are there. Then you have to understand these terminologies very clearly. If it says the cardinality, that is number of rows, how many data rows are there, that is how many tuples. And degree means the number of columns. If the degree is 4, that relation or the table has 4 columns. And relationships actually normally we can get the relationship on the foreign keys informally. And constraint in the informal, the SQL use the word is ascertain. These you have to familiar these words when you want to use the SQL to create that and manipulate the tables and manipulate the data from the tables. So let's try to understand first how to create the table. Creating tables. Table can be created using the create table statement. You can use the create table statement. There are different data types available in SQL too. I will explain not in the today. In the next class, we have some tools for creating the tables very easily, and we can visualize our tables and the relationships also. First of all, you have to familiar with these keywords. Then you can understand those tools, and even the SQL also. MySQL provides the facility to create the tables, and also there are some another open sources. For that I will explain in the next class. And so you have to use these tools to create the tables efficiently with when you write some applications, database application. So you need not to create the tables from these commands, but it will provide some facility to create the table and what we call export it to the servers. When you are going to write the database application, then you can easily connect those database with your application. So here in our in our practical classes, we want to write a simple database application connecting to the tables, to the simple database, and you have to understand how to retrieve the data from the tables as well as how to insert the data to the table. We will try. I will give you an assignment, and you know that you know the languages, and even PHP, using the PHP also we can write the simple database application. We'll try. Okay, then the create table command is used to specify a new relation, that is the table, by giving it name and specifying its attributes and initial constraints. So the attributes are specified first, and each attribute is given the name, data type to specify, and its domain value. So when you each and every data attribute must have a data type, and also we can set the domain values also. For an example, if there is an attribute in the student table GPA, the data type can be given as the real, and also we can set the domain value to the 0 to 4. As you know, the GPA grade point average is not exceeded the 4, and it does not have the minus value, so that 0 to 4, within the 0 to 4, maximum of 4, we can set the value. If someone is going to enter the 5 or 4.5, automatically the database system will give the error message, and you are not allowed to enter the data to that GPA if the domain value exceeds. So that also you have to understand very clearly the advantages of giving the domain values, and possibly attributes constraints such as not null. Actually not null, sometimes we can set as null also. Here is the simple syntax of creating the table. SQL use English keywords and user defined names. You can understand very clearly all the keywords are English, and you can, and also the meaningful English words are used. So create table is definitely you want to create the table. Actually, to specify that, you can write in the capital letters create table, the keyword, and the name of the table, and open bracket. Then you can write the attributes or the columns. The degree of this table is 3. There are 3 attributes. Staff number, that would be the integer, type is integer. We can't set the domain value for this one. Salary, you can find some decimal points, so that float. The last name, character, and set the length of the character. And also you have to understand those data types also will be written in English, capital letters. Char means character, and maximum you can enter the 20, and close the bracket and semicolon, close and semicolon. This is the simple one. And if you want to insert the data, you can you can use the insert into keyword, and for what? The staff table, the values you can enter. Staff number is integer, that is 32. The salary 25,000.0, and name is Smith, and semicolon. Likewise, you can create the table and enter the data to one row, that is to one tuple. And when you I will explain using this. Actually, this is called the semicolon statement are terminated with the semicolon value, semicolon, and commas separate the items in the list, and here in this case we can see like this. If you see in this one, using new side, I will explain. Here we'll see when with this command you can create the table. Table name is staff, and there are 3 columns only, and one is number, and salary, and L name. So by inserting, we can enter 25, salary is 25,000, and Smith. This is the from this command, from this we can create the table like this. So we can enter if we want. Once again, if we write the command insert into staff values, actually 32, we can write the 50, 35,000, and John. Like we can write staff number 35, salary 35,000, and John. How can we write? Insert into staff 35, 35,000, so 0, John. Using this, we can enter the values to this. Okay, let's see so what is data type. The integer, there are several data types. First one is integer. That means we can write the integer or small int. There are 3 types. Int we can define as integer, small int, or the real number. If we have to enter the decimal points, for an example, the salary and the GPA, or else any other value, we can write the float or real or double. Float or real or double. This has some differences of the length of the length that we can enter, the float, real, and the double. According to the number that we have to enter, we have to select the correct data type. Formatted numbers. We can format the numbers as decimal point I and JO. DECIJO number IJ. What is that one? This indicates the total value with the J represent the decimal points. We can limit the decimal points also. Decimal and total values and the decimal points. Then character strings. We can have the fixed length, char, the number of characters, char 25, char 50, or the character within bracket, how many characters, 50 or 25. Also, we can define as the variable length, vacha. What are the differences of these two, fixed length and the variable length? So you can clearly understand this. Actually, when you use the char and put the number, for an example, char 20, likewise the char 20, it means when you create the table, the space is allocated allocated to insert the 20 characters, and variable char is not going to allocate the first allocate the space for this one. It will increase the length maximum of the given value n. For an example, 25, varchar 25, that means the user can enter the maximum of 25 characters, and the length is not allocated first, the memory space is not allocated first, so that it has some advantages. So here from the beginning, the fixed length is allocated the memory for storing, and unless there is 25 characters, the additional space will keep as it is. So the varchar, no such allocation is done, so that we can save the memory space using this varchar. So varchar is very effective than the char. And date and time. There is another special data type that to enter the date and time, that is date and time. Data type are supported in the SQL too. Date and time data type supported in the SQL too. Here is another example. Create table student. The degree is 4, name, address, age and GPA, char 25, address char 25, age integer, and GPA real. If you want, you can set the domain values for the age and the GPA. You know that the age between 0 to 100 or 100, we can't find the student's age more than 100 years old. Actually 100 also, even if you put the 60 or 70 is enough. 0 to 50. And GPA, grade point average, is a real number, that is 0 to 4. And that is not, there is no any value exceed 4 or minus values. So by defining the domain values, you can minimize the errors that you are going to do in the in writing the data to the tables. So once again, we'll try to understand this. The key entity integrity and referential integrity constraint can be specified within the create table statements. Within the create table statement, we can use this, the key, foreign key and primary key, entity integrity and referential integrity constraint. You know what is the entity integrity and the referential integrity constraint. Let's see. Primary key constraint we can use like this, and student ID is, if it is the primary key, you can write in front of this data type the primary key. So don't forget the keywords that you want to create the table, that create table, table name, and column names or the attribute names are here, and data types of the attributes are here. And okay, you can set the domain values, and if it is a primary key, you can write the primary key in front of the primary key. And so alternatively, not writing in front of this SID, you can write at the end of this one before closing the bracket the primary key SID. Here the previous one you can see, you don't need to have within bracket the std id, but in the second method, if you write separately the primary key, you will have to write the sid as the std id as the primary key. So other candidate keys, actually unique values you can write like this. Here NIC, we can't find the same NICs to two person. So NIC, national identity card number, is a unique one. By mistake, if you are going to enter the same NIC number for the different people that you have entered before, you will be given an error message if you set like unique. Okay, this is the one way to minimize the errors, put in the unique. And referential integrity constraint. How to write the referential integrity constraint? Referential integrity constraint means the foreign key. So without the foreign key, we can't create the relationship with other tables. So that you can write like this: the create table grade, and these are the column names or the attributes of this one: subject ID, student ID, and grade. A primary key here is by getting two. There is a composite key, subject ID and student ID, and here the student, which we defined the previously like this. The student, here you can see student ID, name, address, age, GB, NIC, and grade here. If you want to create the relationship with the student and the grade, we can create the relationship using this using this primary key, using this foreign key, student ID and student ID. You can see the grade table also must have the student ID, SID. So here you can see referencing and reference, student ID and SID. This would be the foreign key to the primary key. Primary key is here. This table has both keys. Primary key is subject ID and the student ID. The foreign key is student ID. So the foreign key, where you are going to refer? You are going to references the student. That is references to the student. Foreign key is this. So you are going to reference the student table. Student table. Definitely the std ID must be there in the student as the primary key. Okay. So next we will try to understand the alternate foreign key. Alternate foreign key you can write like this. Create the table, actually student ID, this must come to this place. There is some, I will, okay, I will correct it later. Student ID char 4, STD ID char 10, grade, and STD ID reference the student STD ID, and the primary key you can write at the end of this is the alternate method to give the foreign key in the table while you are creating the tables. Okay. Then after the attributes are declared, then you can declare the attributes, as well as you can set the primary keys and the foreign keys, or they can be added later using the alter table command. So then after declaring after the attributes are declared, you will be given a facility using this keyword constraint. You can write as the constraint FK grade. FK grade is not given here. You are going to put the name, foreign key of this grade. You have to use this keyword, the use of the constraint name. Then constraint, and this is actually you will be given the facility to create to give the name, different name for the foreign key, the FK grade. FK grade is the given name for the foreign key. There is foreign key STD ID, and where you are going to reference the student SID. So this also very, very important. After creating that, you can write like this: constraint foreign key grade. That is, you can give the name. This is a name created by you. Normally you are going to create the name, the meaningful name. FK grade means the foreign key grade table. Foreign key study ID reference, you are going to reference it to the student table. So this the constraint name allows identification of the constraint, which can be dropped later using the alter table command. When you are going to alter the table, you can easily drop. By giving this one, there may have several advantages you can get. Create the, sometimes you need to modify the tables. In such case, if you want to convert this one to the different foreign key, you can easily drop this key later. We'll see how it can be done. So next is specifying not null constraint. You know that the name of the student cannot be null. If the student must have a name and age also, so you can define as not null. That means if someone by mistake mistakenly not going to enter the value for the name, then the system will give the error message that the name cannot be null. So likewise, you can minimize the data entry errors using these keywords, not null, and sometimes unless default value may have not null. In such case, that attribute or that column may have null values. In such case, you can provide the facility to enter the null values also. And default value, you can set the default value for the some attributes or the columns. Address, you can set the default value for Pitipana or the Homagama. That means when you are when you are going to insert the table, automatically the address can have the Malame. And if you want to change, you can definitely change that one. But unless you enter the value for the address, it will get the default value. Default value, that is the meaning of the default values, setting the default value. Then you can check, as I told you, when you are going to enter the data for the student, sometimes the student age normally 0 to 70. We can hardly find the students older than 70. So if we set the value for the 100 0 to 70, we can check these values before writing to the table, and if there are any mistakes, then the system provides the error message. For an example, this employee table, age integer value, the check age between 0 and 120. So when someone is going to enter the age for you know that the employee also, they can work from until 70 years old. We can hardly find the employees who are working after 70 years old, but there may have some. So, but after 90 years old, no one can be found from the industry. So, we can set the age between 0 to 120 or 90. Then, when the data is going to enter to the table, check the age is in between the 0 and 120. In this case, it gives 120. So, the referential triggered action. Referential triggered action, what is that? The default action of that SQL takes for an integrity violation is to reject the update operation that will cause the violation, which is known as the restrict option. Restrict options. And however, the schema designer can specify an alternate actions to be taken by attaching a referential triggered actions, referential triggered action clause to any foreign key constraint. The option include the set null, cascade, set default, and option must be qualified with either on delete or on update. So sometimes if I tell you, you may not have you will not be able to understand. I will explain using an example. For an example, there are two tables, the student and the course. Student and the course. So we'll write the student has the name, address, GPA, course ID, and other course ID and GPA. Okay. Course has course number, student number, and semester offered or something, course number, course name, student number, only that one. Okay, then when you are going to delete the student from that course, you have to give on delete the student from the table, or on update. When you are going to update one table, definitely you have to update the other tables also. Otherwise, there may have some inconsistencies of the data. So, when you are going to update, what would happen the data related to that field in the other tables? So, you can set null or cascade or set default values. Set null means for those rows you can set the null values. Or cascade, you can delete all these rows. Or set default values. If those columns has default values, you can set the default value. So that is the reason. And so it must be qualified with the either on delete or on update. If you are going to delete the data from the table, definitely you have to set the one of these: set null, cascade, or set default values. Here the referential triggered actions operation on update and on delete actions: set null, cascade, and set default. Set null you can put as a set cascade or set default. We'll discuss from the examples. Here, create the table employee. The NIC, name, address, and works in. The NIC is given as the primary key. Name is the unique, not null. Unique and not null. Address, default column. Set the default values. Works in, you can see you have to enter the integer number where his was. Constraint of the foreign key of employee department. So this will connect to the employee department that he is working. The foreign key works in here, works in keyword. And reference department, this is to the reference to the department, and department also there may have the number works in. And on delete, cascade. On update, no action. That means sometimes what would happen if this employee, consider that employee resigned from the department, what would happen? We'll write, we'll explain, we go to the next one and see. I will explain using tables. There is a table employee, we'll write here employee. You can write the columns NIC and write this name, address, works in. Name, address, works in. And also there is another column table department, name, works in, NIC. What NIC and we can say another address or something like that. Here the works in is the foreign key and here it can be connected to this work scene, and name and work scene is the primary key. Both these are primary key. And also NIC is the foreign key. You can see here, you can work scene is the foreign key, and primary key. Okay, you can enter the data. Default value is address is Colombo. NIC is 1 2 3 4, let's say. Name is ABC. Person works in department 01, and department name finance, works in department 01. NIC 1 2 3 4 is working address. The place of this one, let's see, Colombo, head office. Consider that. Then 5 6 7 8 CDE goal 0 1 finance 0 1 5 6 7 8. So consider that this person is going to resign from the company. This person is going to resign from the company. ABC person, or we'll see the name as ABC person. In such case, when we are going to delete the data from the table, this the data related to this person can be seen here also, here. So when we are going to delete the data, we have to delete the data from the reference table also, so that we can do 3 actions. On delete, set null. That means after deleting this one, we can set the null values for this one. Null or null. Likewise, null values for all columns. Or on delete, cascade. That means when the row is going to be deleted, the related data also deleted. And another one is on delete, set default values. If there are some default values for these, you can set the default values. Otherwise, you have when you are going to delete the data from one table, the data related to that can be seen from the other table, so that in order to keep the consistency of the data, you have to do this one. You have to do on delete, set null, cascade, or set default, or on update also set null, cascade, or set default. That's how we have to set these values. Okay. On delete, cascade. Cascade means delete all this. On update, no action. On update, no action. You can put no action for this one. Okay. Drop in the table. Sometimes you will have to drop not only the row of the table, but also you will have to drop the whole table. That means you can do this one: drop table, employee, restrict, and cascade. Restrict, drop if not other constraint. You can drop it if there is no any other constraints such as foreign keys or review exit. So if there is no any foreign keys there, you can drop the table. Cascade drops all constraint and view that reference it. In the cascade drop all constraint and views that it reference. So you can delete the data, but you have to keep this one. The SQL Server 2000 has only restrict option, which is in the default. Restrict option which is in the default, but you can't find the cascade. And next one is altering the table. How to alter the table? That means you will have to add the columns for the table, or else you have to delete one column from the table. That is alter the table. Alter the table can be used to add or drop a column. As I explained, this can be used as add or drop a column, change the column definition, or adding or dropping the table constraint. You can add the column, you can drop the column, you can change the definitions of the columns, and you can drop the constraint if there are any key constraint there. Okay, alter table employee, add job vacha 12. That means you are going to add a column. The column name is job. The type is the variable cha 12. Maximum of 12 characters can be entered. The new column has null values, hence not null cannot be used here. So you can't put the null. By default it is not null can be used here. The not null cannot be used here because by default it has the null value. Dropping column. If you want to drop the column, alter the table, the employee table you want to alter, and drop the column job where you have added the previous command. Here you can see add column name, the type, and you are going to drop that one. Drop column name job. Column job. You need not to put the type. Change in the column definition. Sometimes you can change this column definition. How can you use? You can use alter table employee, alter column job vacha 50. So earlier it has vacha 20. You want to give more length to enter the name of the job, so that you can change as vacha 20. Instead of 20, it will change to the 50. Drop in the constraint. Also you can drop the constraint and drop FK employee department. And earlier you have created the constraint for the foreign key using these commands. You can see constraint FK employee department foreign key works in, and reference on delete department, on delete, and on cascade. So you can see the FK employee department, the given name for this constraint as the foreign key, the works in. Now you can drop it, and if you want to add a new one, you can drop it as drop in the constraint alter table employee, drop FK employee department. That's what these are the advantages of giving the different name for the foreign key, constraint and foreign key, name of the key. This name is given by you, so that if you want to drop, you can easily drop by giving this name only. If you forget, once again I will explain. Here you have given this one, FK employee departments constraint. You set the foreign key. Foreign key, this one works in. The reference to the department, for the department. Then FK employee department, this one works in. The reference to the department, for the department. Then FK employee department, this one works in. The reference to the department, for the department. Then FK employee department, this one works in. The reference to the department, for the department. Okay. Next one, we can modify data using the following three commands: insert, delete, and update. So that after creating the table, earlier I explained how to create the table, how to insert the constraints and the domain values, as well as how to set the foreign key and primary key, and how to set on delete and on update. And now we can let's discuss how to enter the data and how to modify the data in the table. So we can modify the data using the following three commands: insert, delete, and update. If we want to insert the data to the table, we can use the insert into the table name, that is department. And values, you have to enter the values in correct order. Department number, sales, then the address. This order must be there in the table. While you are creating the table, you have given a certain order. Otherwise, if you make some mistakes, the data types and the attribute names may differ, so that you can't enter the values correctly to the table. So in the order of the value must be the same as the create table statement. So this is the main thing you have to understand. Order of the value, order of these values must be same as in the create table statement. In the create table statement, you can you have given us you gave a certain order. In that order you have to enter, and also the data can be separated using the comma, and also the cha or vacha can be entered in the single quotation, within the single quotation. Integer values can be entered as it is. Inserting the user-defined columns. Inserting the user-defined column, as well as you can select the columns. Insert into the employee table NIC name and works in, NIC name and works in only values, NIC number, name, Ajit Peran, works in is 1. Only the columns are specified are filled with values. Unspecified columns are filled with none values. In such case, if you specify the columns like this, the values will be entered to the specified columns only. Others columns fill with null. So there are two ways here. Insert into the name and values you can give, or else insert into employee, you can give the attribute names or the column names and values. If you give the value column names, the data will be entered to the given columns, and other columns set null. Inserting multiple rows. Insert into employees select statement, and we will learn this select statement in detail later. Don't worry about it. So then, deleting the tuples from the tables. Now you want to delete one row that belongs to one person or one department. If it's an employee and if it's a department, one row can be deleted. Deleting all records. Delete from department. That means if you want to empty the table, you can write delete from the table name. And deleting only the specified record. If you want to delete on the specified record, delete from the table, and where you can see the selection condition. Delete from where the selection condition you will have to give. Delete from department where department number is 2. If you want to select the department 2 and delete all the table, all the rows of the department. So delete from this department table, the condition is given where the department number is 2, department number is 1. Then you can delete all the rows related to the department 2. And completely removing the table in a DDL operation, as well as you can completely remove the table in a data definition language operation. Drop table staff. In such case, you can write the drop table. Here from the delete and the drop, what are the differences of that? In the delete table, the table is there, only the data will be deleted. But drop the table, from the drop the table, you can drop or the delete the table completely. After that, you can't find the staff table in the database. But here in the delete from department means the department table will remain, the data will be deleted. And drop means you are going to completely delete the table itself. And next one is updating tuples in a tables. How to update the rows in a table. Update table, set column equals expression where selection condition. This is the syntax of updating the table. Let's try to understand. Updating all tuples. Update employees and set works in is 1. You want to update the employee and set the set 1 to the works in. Set 1 to the works in column. Works in column, you want to set 1. That is update all tuples in one command. Updating the selected tuples. If you want to update the selected tuples, update the employee, set the works in 2. Set the works in 2. The condition is where NIC number. NIC number is this one. You want to update one tuple and you want to transfer this person to the department 2. In such case, you have to update from the department 1. He is working in the department 1. You want to update it to the department 2. Then update employee table, set works in, select the works in, set the works in column to the 2 where the condition is NIC number of this one, only this person. Change the works in department. Here student name, major and GPA. Student number 1, name Sampath Nishani, major EE CSC and GPA 3.5, 3.4. Consider the following schema. Student number, integer, name, Vacha 50, major, Cha 4 and GPA. Write the SQL statement to perform the following. Create the above table. Insert the following information. This is simple exercise actually. I will give you here. Exercise is update Sampath's GPA to 3.7. Delete student table. Add columns. Column address Vacha 50 is the student table. Change the data type of the address column into the Vacha 100. All I discuss. Add the checking rule to GPA column. GPA values should be between 0 to 4. Remove the checking constraint to the GPA column. Create table major, and this one change the student table to reflect primary key. So this is the homework. Actually, you have to do this one at your home, and I'm going to discuss in the next class. And today we discuss the SQL, that is standard query language for relational database management systems, and three main categories of SQL, that is DDL, data DCL, and DML, data definition language, data control language, and data manipulation language. And the create belongs to the data definition language. So that's all for the lecture 6. We